Hi chemistry students, this video is going to talk about limiting and excess reactants and what those things are. It's also going to give you a slight introduction to percent yield, actual yield, and theoretical yield. I know we don't have homework on that yet, but I just want to put it all in one video so you don't have like a 30-second video to watch next time. So to start, we're going to start with the term limiting reactant. Make sure you're following along in your notes right now. So limiting reactant is just a reactant in a chemical reaction that determines the amount of product formed. Okay, it's what's limiting. So we did a s'mores lab a while back in general chemistry. You had an opportunity to do that at home if you had the ingredients. But basically, a limiting reactant determines how much of something you can make. So for example, if you had 4 graham crackers, 5 marshmallows, and 3 pieces of chocolate, how many s'mores could you make? So let me write that out behind me. So if you had 4 graham crackers, 5 marshmallows, I think that's an M, but I don't know what happened there, and 3 chocolate pieces, how many s'mores could you make? In a s'more requires 2 graham crackers, 1 marshmallow, and 3 chocolate pieces. So if we had these materials, we have enough graham crackers to make a total of 2 s'mores. We have enough marshmallows to make a total of 5 s'mores. But we only have enough chocolate pieces to make 1 s'more. So the chocolate pieces would be our limiting reactant because there's limiting the amount of s'mores we can make. The limiting reactant isn't always what we have the least amount of. It's also determined by how much of it is required to make something happen. But the limiting reactant is what's limiting things from happening. Okay? So let's do a problem that involves that. So let's say we have the problem, silicon dioxide plus 4, I think that's hydrofluoric acid, yields silicon tetrafluoride and 2 molecules of water. So if 6 moles of HF is added to 4.5 moles of SiO2, what is the limiting reactant? So with these types of problems, we're given several different things. We're given our overall equation, which we're going to have to use. Remember, when we're doing stoichiometry, we have to have a reaction because we're doing reaction stoichiometry. We're basing everything on a balanced chemical equation. We're also given 6 moles of HF, and we're given 4.5 moles of SiO2. And it's asking us, what is the limiting reactant? So in this situation, we're just going to ignore the water and see what is the limiting reactant when we're trying to create SiF4. So notice we're given 2 different things. We're going to be solving 2 different problems. And I'm going to do those behind us on the board. Alrighty, so there is our formula that is given to us. So our first thing that is told to us is that 6 moles of HF is used. So we're going to start with 6 moles of HF. And we're also given 4.5 moles of SiO2, silicon dioxide. And we're trying to figure out which of these is limiting when we're trying to produce silicon tetrafluoride. So what we need to do in this situation is convert both of these in a mole-to-mole problem. So we need to turn the moles of HF into moles of SiF4 to see how many moles of SiF4 we can create. To do this, we need to know our mole ratio, and our mole ratio between HF and SiF4 is 4:1 or 1:4. So when solving these problems, we have moles of HF on the top, so we need moles of HF on the bottom. And we're going to convert this to moles of SiF4. We know we have moles of HF on the bottom, so we're going to use our 4:1, so 1:4, 1 mole of SiF4 to 4 moles of HF. If you're confused about how I'm doing this, make sure you go back and visit our mole-to-mole conversion video. So now we have moles of HF on the top and moles of HF on the bottom, so we're able to cancel that out. And then when we divide 6 by 4, we're going to get 1.5 moles of SiF4. So that's how many moles of silicone tetrafluoride can be created from 6 moles of hydrofluoric acid. Okay, so now let's turn this amount of moles of silicone dioxide into moles of silicone fluoride. Our mole ratio here is a 1-to-1 ratio. So that's a pretty easy math sequence here. We have 1 mole of silicone dioxide is equal to 1 mole of silicone tetrafluoride. Can cancel our moles of silicone dioxide. 4.5 times 1 divided by 1 is 4.5. This is where it gets a little tricky, but also not too hard. When you're done calculating both of the moles of the silicone tetrafluoride, you need to compare both your answers. So we have 1.5 and 4.5. You find the smaller number. 1.5 is definitely smaller than 4.5. So HF would be our limiting reactant. Okay, HF is our limiting reactant because it's the compound that produces our product in the least amount. Okay, so that's what a limiting reactant is. I'm going to include another supplemental video in case you want some more practice on that. So then, opposite of limiting reactant then is our excess reactant. Our excess reactant is our reactant with a greater amount than necessary. It's what we have extra of. Okay, an excess reactant is what we have extra of. So in that example that I gave you earlier of s'mores, we would have had extra marshmallows. We could have had made so many s'mores if we had everything else because we had 5 marshmallows. Okay, so in the problem we just did, HF was our limiting reactant and SiO2 is our excess reactant. So those are opposites of one another. Next, we're going to talk about a theoretical yield. A theoretical yield is the amount of product you should receive from a chemical reaction. I know you guys are online students, so you haven't been doing a lot of labs, but when you do anything in life, generally you expect to get a certain outcome, or you expect to make, let's say you're baking cookies, you expect the recipe to make 12 cookies, but the recipe only makes 10. Your theoretical yield there would be 12 because you're expecting to make 12 cookies from the recipe. Okay, your theoretical yield is what you should be making. Whereas the opposite of that is an actual yield. So for example, when finding a theoretical yield, you use the limiting reactant to calculate this, okay? So the smaller amount. When you're finding a theoretical yield, you would do this like in a lab setting. You do the experiment, but before you do that, you calculate how much you should create. And you're going to base how much you should create based on the limiting reactant. Like I was saying before, the opposite of a theoretical yield is the actual yield. So that's how much you actually make from your reaction. Your theoretical yield was 12 cookies, but you actually only made 10. So 10 cookies is your actual yield. You find the actual yield by doing your final minus your initial. Okay, so not too crazy difficult. Lastly, percentage yield. Percentage yield is the ratio of the actual yield to the theoretical yield. So how do these relate? It's kind of calculating how much, like how accurate were you? How much did you actually make? So I was supposed to make 12 cookies, but I only made 10. So what percent yield did I get? How many cookies out of the percent that I should have made did I get? To solve this, you're going to use this formula, actual divided by theoretical times 100. So we're going to do a little practice problem with this together. So when 36.8 grams of C6H6 reacts with an excess of Cl2, the actual yield is 38.8 grams. What is the percent yield? Okay, so we're given several different things in this problem, but we're also not given a couple of things. So let's take a moment and identify what we are given. I'm going to try to make myself big, but not too big here. Can I stretch myself? Sorry. I guess I'm going to have to make myself bigger. And you're just going to have to remember the problem. So give me 1 second while I write it on the board. Okay, so When solving this problem, I have our formula up on the board. Remember, our first step is always to make sure this equation is balanced, and in this case, this equation is balanced. This equation gives us a couple different things in the problem. It tells us 36.8 grams of C6H6 are reacting in excess Cl2. When it says excess Cl2, we're going to ignore the Cl2 because it doesn't matter. It's telling us there's enough of it, so we don't need to pay any attention to it. It gives us our actual yield. It tells us our actual yield is 38.8 grams. And it's asking us for our percent yield. Remember, our percent yield is equivalent to our actual over our theoretical times 100. We are given our actual yield, so we can plug that in. So 38.8 grams goes on top, but we're not given our theoretical yield. In order to find our theoretical yield, we need to take this given value of C6H6, which is benzene, and see how many grams of C6H5Cl it can create to get our theoretical yield of that compound. So let's take a moment and convert that. So we have grams of C6H6 on the top, so we need grams of C6H6 on the bottom, and that's going to be equivalent to 1 mole of C6H6. To find this value that goes here, we need to find our molar mass of C6H6, so we're going to do 12.01 times 6, because that's the molar mass of carbon, plus 1.01 times 6, the molar mass of hydrogen, to get 78.12 grams of C6H6. We have grams on top and grams on the bottom, so we can go ahead and cancel that. Let me switch sides. Our next step is we have moles of C6H6 on the bottom, and we need to somehow get to moles of C6H5Cl. And we're going to do that using our mole ratio, and our mole to mole ratio here is just 1 to 1, so it's a pretty easy one. Cancel out our moles of C6H6, and now we're at moles of C6H5Cl. Notice our actual yield is given in grams, so our theoretical also needs to be given in grams, so we need to turn this into grams. And we know that 1 mole of C6H6, or Cl, is equal to our molar mass, and our molar mass of this compound is 112.56. So when we solve this problem, we're going to multiply across the top and divide by the bottom to get an overall answer of 53.02 grams. We're going to plug that value in here for our theoretical yield. We're going to divide those, multiply by 100. Haven't done this step yet. So we have 38.8 divided by 53.02 times 100 to get a 73.18% yield. Okay, that's not a great percent yield, but it's also not the worst. Again, I'm going to include some other videos for you guys to watch to get some extra practice with this. I think that's the last thing I have for you today. As always, make sure you continue to add to your booklet, add those new couple things we just learned. Otherwise, let me know what questions you have. Thanks.